Hi everyone, for this question, it asks us to find the integration of the following integrals. For the first question, we're going to integrate 3 over 2x minus 4. So first of all, you're going to check whether we let the form of the question in fraction. So the condition is when you see the denominator power 1, so 2x minus 4 is power 1. When the denominator is power 1, we will let it in fraction form. So when we let it in fraction form means we might use the formula number 6, which is integrate about fraction. And your fraction denominator has to be linear. So if you have denominator is linear, we can integrate using formula. Straight away, it will bring us ln ax plus b over coefficient of the x, which is a, then plus c. So this is a formula for integrate fraction. Back to these questions, what can we do? We can factorize 3. Then we can notice that our denominator is fraction. Our numerator is 1. So we have this pattern. We integrate using formula. Straight away we can get ln 2x minus 4. Don't forget we need to divide by the coefficient of the x, which is 2. Then plus c. Or you want to write it as 3 over 2 as a coefficient also can. Ln, we put modulus for the purpose we want to make sure this logarithm function always positive and it can be valid for any value of the x. So that's all for the first part. Then when we come to second part. So when we have second part where our denominator no longer linear, we might need to check whether it is the special form of the fraction where it is a function, up here differential function. If it has this pattern, it will be ln to the fx plus c. So this special form will be applied when our denominator is not linear. So let us check this question if our denominator function is x squared minus 2x minus 8. And when we differentiate, we're supposed to get 2x minus 2. Even we factor out the 2, is supposed to get x minus 1. So look like we have x plus 1 totally different, means our function cannot be worked. Our formula also, we don't have that pattern. So when we don't have formula related to the integral, we will move on to technique of integration. For solving the fraction, technique of integration needed here will be partial fraction. So express this in partial form. In partial fraction, the first step, we'll make sure our fraction is proper. As you can see, linear over quadratic, this is proper. Then second step, make sure our divisor is factorized completely. So this quadratic we can factorize. It will be minus 4 plus 2. After we factorize completely, third step, we will split according factor. Factor of x plus 2, factor of x minus 4. After that, we determine the numerator. When this is linear, numerator will be constant. Then when this is linear, up here will be constant b. Then next step, equal the equation. So a will time with the factor it don't have. It already have x plus 2, so it will be times with x minus 4. For b, it will time x plus 2. Then we start let two value of x, because we have two variable we want to find, two unknown we want to find. So we need two information. Let the x to be the roots from the factor, x equals to 4 and negative 2. Then you will get the value directly. Substitute x equals to 4. A will be eliminated. So this one will be 6b. B will be 5 over 6. Again, substitute negative 2 into the equation. Negative 6a. So a will be 1 over 6. Then we rewrite our fraction in partial fraction form. A is 1 over 6. B is 5 over 6. Then for the part 2, only we start integral using its partial fraction. So integrate this plus integrate 5 over 6 x minus 4 dx. So you can see our fraction denominator is power 1 and denominator is linear. So this one can integrate using formula. You get ln. So before we using the formula, we factorize out 1 over 6. Integrate 1 over x over 2. It will give us ln x plus 2. Then this one we factorize out 5 over 6. Here we get ln x minus 4. Then plus d. So that's all for this.